Hello, everybody. Thank you for coming in. Good afternoon. My name is Siva Guru Reddyar. I'm a senior specialist architect here at AWS. So welcome to this session on comprehensive observability with mobile real user monitoring and application map. So with me, I have Alex, who is a principal engineer at AWS. And we would like to talk about this as a code talk, right? We wanted to have it dive into the code and then talk about the various features and all those things, right? But before getting into the weeds, how many of you here, just show me your hands if you are using application signals in your product or in your company? Maybe that's a bad marketing on our side. How many of you have heard about application signals? Good. Yeah, so application signals is our own way of doing APM, right? Application performance monitoring. And I would like to level set the field, we will be taking a very short, maybe theoretical concept on what is it all about. Then we'll dive into the coding things, right? So this is what our agenda is going to be. We'll talk about the overview on a very high level. Then we'll talk about the latest and greatest features, including application map, the mobile real user monitoring, which we just launched a couple of weeks back. And finally, we'll get into the code things. So application signals, as I said, it is on a high level. You can think of it as our own version of application performance monitoring. So we have inventory of services that you're running in your application or in your account and all those, right? And you wanted to both understand, monitor it and observe it. And when things are failing, you want to fix it ASAP. So that's what it's all about. So we will be showing, irrespective of whether you are instrumenting it or not instrumenting it, we will be showing you all the services that are available in your account from the console. We'll be showing a demo. And also, it's all based on golden metrics. In the APM world, the golden metrics is all about red metrics, we call it as, wherein R stands for request, E stands for errors and false, and D stands for duration or latency. So everywhere, in application signals console, whatever you will be seeing, it's based on golden metrics or the red metrics and dependency tracking. But the beauty here is, you're not sending us any kind of metadata that says, okay, hey, my service A is calling service B. We will be getting all the tracing information based on the distributed tracing, and then we'll figure out what is your dependency is. It's all based on open standards. We are using open telemetry as the underlying mechanism. And using that, we will be showing you all the details. So with that one, as a next level, you want to connect maybe your technical things with your business metrics. So that's where you can create your SLOs, service level objectives, from your services. And also, the topology map will be showing you how these services are interrelated with each other, as and when your services are sending metrics to us. So with this one, like we discussed, it is based on distributed tracing. And last year, we introduced the concept of transaction search. So what we are doing is, we are taking your traces and then storing as logs. So in that case, any kind of transactions that are available in your business applications, you can go ahead and then search for it. The typical way you will be doing with CloudWatch logs, right? So we can do that. And last but not least, we have support for real user monitoring as well as canaries. So real user monitoring, predominantly we have been supporting web for a pretty long time. And recently, we added support for mobile applications, both iOS and Android. And as well as synthetic canaries, if you wanted to run any synthetic testing on your APIs, on your endpoints, that is also supported. So let's talk about the newer feature called application map. So it has come a lot of stages. So we started with trace map, then service map. Currently, it is in the stages of application map. So application map, it is, so you are seeing in the upper, right-hand side picture. So that's how you will be seeing it. We will be showing you a demo on this. So here is where you will be seeing a lot of tiles. So these tiles are representing your applications, and then we are grouping together by related services. So that is our default grouping. But you can go ahead and then create your own custom grouping. Either there is a front-end grouping and then there is a back-end grouping, or if you are running multiple BUs, for example, I might be running a GFS application, right, a financial application. So that could be my BU could be a loan BU, could be one tile, and then my lending could be another BU tile, right? So that way you can go ahead and then segregate your applications the way you wanted it, the way you wanted to observe it, right? But the thing is, if you can click into that one, so that's how it is going to be elaborating. So each and every service with its dependencies. So that's the lower part of the picture is showing you can do all these things from one place. Again, each and every tile, you can click on it like a recursion basis. You can keep doing the drilling down till the way you wanted it. So how you do navigate the map? So as I said, we can group by the way you wanted it. By default, the grouping is the related services, how you are sending the metrics. But as I said, you can go ahead and then group it, and then you can zoom it and zoom out and all those things because it's a map. So wherever you need the attention, you can zoom in and then zoom out and then do all those things. And also, if you see in the right-hand drawer, there is something called, there is a lot of details around it. Starting with your health metrics of your services. So in this case, I do have a pet clinic frontend, which is showing how healthy my service is, how many falls I'm getting it. And then if I created any SLOs, how they are healthy or unhealthy, those kind of information. In addition to that, as I mentioned, you will be seeing all your red metrics, the number of requests you are getting it, your errors, falls, then latency, all that information is available. And one additional thing is the support that we recently added is there is something called operational audit. So operational audit is something like we are proactively saying to you that, hey, this X service is having some latency issues. Can you take a look into it? So it is not the reactive days are all gone, right? Now people wanted to do more of proactive stuff. So in this case, it will tell you, so not only tell you there is something happening, but if you wanted to take a deep dive, you just click on that one of the traces that it will be showing you, and then it will tell you exactly how it is coming to the conclusion that it needs some attention. So let's switch gears and then talk about real user monitoring. So real user monitoring, as I said, if you wanted to record all your user interactions from browsers, your end user might be using their browsers to get some insights from their browsers, you might be using real user monitoring. And we have been supporting this web for a pretty long time. And we recently added the support for both Android and iOS. And with this one, you can get a lot of information around it. For example, again, how healthy is your application, or both mobile as well as web. And then in terms of web, you will be having a lot of details around how many JavaScript errors I'm getting, or is there any JavaScript errors, or in the mobile world, it could be the number of crashes, those kind of stuff, right? So you'll be getting numerous information from this particular charts, and also when we are extending to mobile, so these are all some of the charts you are getting it, right? First one is comprehensive dashboard. So that's where you will be seeing both your performance metrics and then your crash analytics and all those information. And all these things are coming in real time. So when a customer is getting a crash from their mobile application, it will be recorded in application signals or real user monitoring, so that there is not much leniency there, right? So the moment they are getting it, you are getting it in real time. And also when we are talking to many of the mobile app people, they wanted to see the important things around how much time my app is taking to load, or the application performance index, those kind of things. Again, the mobile world is splitted. There is iOS, there is Android, and then here in Android world we call it as ANR, or application not responding. But in the iOS world we call it as crash analytics, right? So depending on the kind of mobile application we are talking about, we provide you both the information in the same language that the mobile developers are using, right? So if you are using iOS, we'll show you all the crash analytics. And if you are using Android, we'll be showing all the ANR details. So with this one, you are also getting the various information which iOS they are running, or which version of Android they are running, what type of device they are using. So all those kind of information, we are capturing it, and then those information are available to you. So we talked about two different things, right? One is your services which are running in the backend, and then the another world is the real user monitoring, which could be web or mobile, right? How they are interconnected with each other. So for that, we are using correlation IDs. The moment, your customer is doing some operation, we will create a correlation ID, and then that correlation ID is being tracked over multiple hops. So this is based on open telemetry, open standards. And again, the end-to-end transaction tracing is available for you. So once there is an error that is happening, you can easily track it all the way from your mobile application to your backend service. And also with this newer application map feature, you will be having automatic topology discovery as well as visualization, so that from one place you will be able to see how things are interconnected with each other. And also it is showing you the service dependency as well. So you might be wondering how my A is calling B and all those information. That is also available for you. And also the performance metrics overlay at each tier. I don't know whether you noticed it. Every tile will be having a donut chart. So the donut chart is color coded. So every chart, when you are having some issues, it will be showing in red. So that needs it needs some attention, right? So on a high level, if it is a 1,000-foot overview of your application, you can easily see which tile is showing you red or green, those kind of information, so that it's easy for you to figure out what's going on. So it's easy for this bottleneck identification and visual indicators using that one, right? So with that one, this is how the architecture is. From your mobile applications, you are sending, whether it is iOS or Android, you are sending your telemetry to CloudWatch Real User Monitoring. From CloudWatch Real User Monitoring, we will do the job of taking those metrics and then sending it to Application Signals. And in the bottom side, you have your backend services. So with this backend services, you are sending your telemetry as well. Again, everywhere it is open telemetry, open standards. And if you are a user, so in this case, assume we are seeing from the right-hand side. We are seeing from the right-hand side with this application signals and application map. So using that, not only you are going to monitor your applications, and if something is breaking, we are going to see how you are going to fix it. So that's what all about the code we will be showing you from Alex. So with that one, let's go with the code.
Hi, everyone. As software engineers and system architects, how many times have you looked at the architecture diagram, something like this, and thought to yourself, well, this is like some really ugly spaghetti monster right there. And how many of you actually build a system like that? I did. My name is Alex Nazarov. I'm a principal engineer in CloudWatch. Many projects start with simple, beautiful architecture. But then your business grows, you add features, you add redundancy, you add security, you add search index, you add analytics. This list goes on and on. And so you get the idea. Eventually, the system becomes so difficult to comprehend. Even people who build that system 6 months down the road will have a hard time understanding what's happening under the hood. You see, the problem is not that distributed systems are over-engineered. The reality is that real user scenarios, real-life scenarios, requires building complex systems. And this system stretching human abilities to understand and keep track of what's going on in the system. So when we approached this challenge, we talked to our customers. And they said, you know what, instead of this, I want to have a way to look at all that I have in all my accounts on one page, kind of like this. So show me on the high level what I have, and also help me to understand the status, like health status of each application. But when I'm interested, I want to dive deep, like go inside, and see its guts, see what's happening under the hood. But then I should be able to go back, zoom out, and look it up on the high level. So we use this as a guidance when we worked on this new application map. What we introduced here is dynamic grouping. So what application signals in this map is trying to do at its best effort is to discover resources like API gateways, load balancers, EKS, ECS clusters, EC2 autoscaling groups, and use them as a backbone that, or like a tip of the iceberg that to present a structure that forms applications that you're hosting on AWS. Previously, application signals only worked with instrumented sources. You would have to instrument your code. But we just recently added functionality that, like I highlighted on this map with the dotted lines. These are the applications that we believe just entry points into something much bigger. It's not instrumented, but you still have all the benefits that like minimalistic APM functionality for these services. So for example, I have this ticketing light service. It essentially allows customers to submit tickets. When I explore details for this application, I see, first of all, there are like, it discovered 4 services under the hood. It tells me, it's breaching some SLOs. These are the most recent deployments for this application. This is taken from CloudTrail. And the golden signal metrics, like availability, some latency, server faults, user errors. I can go dive inside of it. And again, everything is a dotted line here. It means it's not instrumented, but it's pretty straightforward. I have a API gateway, and it has 3 Lambda functions that implement some of the APIs backed up by this list tickets, read tickets, submit tickets. Pretty straightforward. And even from this map, I already can see that, okay, I have issue that my customer is facing because it's an API gateway. And then it's actually going into the submit ticket. So submit ticket has issues. From this, overall description, I can only see, well, it got deployed recently. The deployments are marked as vertical lines on the graphs, but I don't see any correlation with deployments. So at this point, the best idea for me would be to instrument this application. I can go and instrument each individual Lambda separately, or on the high level, I can just use this context menu to enable application signals for all of the components inside of this application. So here I can just click enable on all the Lambdas. What's going to happen is that this enablement will add open telemetry layer to these Lambda functions. It will not add the agent, but only the SDK, the client side, that will talk to OTLP endpoint. So the benefit of that is that you're actually not wasting resources on the agent, and it does not increase the agent does not increase the Lambda cold start. So the enablement takes roughly 5 minutes, so I already have a carbon copy of that ticketing service over here that is already instrumented. So now when I look at instrumented version of that application, I see more details, right? So now I can see that, okay, this is that problematic submit ticket Lambda, but it also brought in another Lambda and this SQSQ. So this is how they communicate asynchronously with each other, also showing me the tickets DynamoDB table that these Lambdas are using. So I got much better picture about what is actually happening right now with my system. And after instrumentation, what is also available to me is this operational audit. On the high level, operational audit Just goes, finds what you would do manually, just find traces, find exceptions, and it just surfaces it up. So you can actually not diving into the logs or doing any complicated research. You see exactly, okay, this Lambda called SQS, and this is the exception message that says, well, you're trying to submit too big of a message to the queue, and it doesn't accept it. And this is how we got that exception. Now, what I want to also show is that this audit is available from your dev environment, like IDE. So in this case, I'm showing Kiro, but VS Code with client would do exactly the same thing. I have here pre-installed CloudWatch Application Signals MCP server. And the way to get it is actually it's available on AWS Labs under MCP folder. And there is a CloudWatch Application Signals MCP server. So what I can do now, this IDE talks to the telemetry that captures the state of my production. I can ask questions like, which services are breaching SLO? And right now, it actually went, scanned that map, list of services, figured out which ones are breaching SLO and reporting this to me. And I can also, with it, individual services, like I can say, well, what's wrong with that submit ticket, right? So submit ticket is gonna execute public API available that you can also use that runs the operational audit. And from this operational audit, it makes the same conclusion that we just saw that message on the screen. It's saying you trying to submit messages bigger than the queue can accept. And the benefit of this is that you can essentially do your root cause analysis, troubleshooting from IDE, and instantly connect your code with what's happening with your services in production. And the IDE already knows, like, because you loaded that code base in IDE, it connects that stack trace that it found in telemetry, and it says which line of code is causing this problem. It suggests remediation or fixes how you can actually mitigate that problem. Okay, so now let's go back and talk about how to customize this map. So right now, what you're saying here is best effort to group all services, what we call like related services. Essentially, many applications have an entry point, like a load balancer or some front-end service, API gateway. And this is what we're discovering and showing, yeah, like you have, this, for example, appointment service. It has like this microservices. This is how they related to each other. There are some components that not connected with anything. They have their own like standalone version. But we also allow you to customize this map. And so by default, you could see also all the services grouped by environment. So by environment, you can use OTel attributes and say deployment environment.name, and that way you can differentiate your production versus test, performance, etc. So that way you can regroup all your services by environment. But in addition, we have this way of custom grouping. So it's a little bit involving, so bear with me for a moment. So let's say I would like to have different groupings of all the resources and all the services I have across multiple accounts. So I would create these groupings over here. Like I want to actually control myself what composes my application. So I have created a grouping by application. Another part that's important to me is tiering, like tier 1, tier 2 service, like how it's important to my business. And then team ownership. I can, assign services to the teams who operate on them. So this on the left side. On the right side, what I'm specifying here is AWS tags. These are the tag names. So if I have a name, tag named application or app.name or my app on API gateway, the value that this tag is carrying will be the name of that application. The same with the tier and the team. So these are just AWS tags that I'm saying should be used to create grouping. In addition to AWS tags, we also support OTel resource attributes. I brought them here. So OTel resource attributes is when you instrument your code, you have a chance to define additional key value pairs for these services that get instrumented with OTel telemetry. So and this is what you could use alternatively to the tags. You could use just OTel resource attribute and pretty much do the same thing, specify that this microservice belongs to, let's say, pet clinic application. So after that is configured, give it some time, and when telemetry gets ingested into CloudWatch, the application map will form with these custom groupings. So for example, this is the grouping by application because I have annotated my telemetry or annotated resources with AWS tags with these values of telemetry. And this is example of, let's say, tiers. And this is how I can work. I actually can chain this grouping by. I could start with tiering. Like, let's say the most important to me, I want to work on tier 1 services. I see they all in red, but I'm interested in tier 1 first, right? So I go inside, and it's quite complicated. So I can group for the second level. Say, well, now I just want to see them by application. Well, there are actually 3 different applications in tier 1: payment, pet clinic, ticketing system. Then I can go essentially inside of them and inspect that, let's say, this application, pet clinic, right? Or I can go back up, and regroup by applications and see what's available in this account. So let's actually dive into pet clinic and what this.
By the way, if you have any questions, please ask it. Let's make it as interactive. If you have any questions, please feel free to ask any questions. Sorry, Alex.
No worries. So what we try to achieve here is that's what customer sentiment was. I want to use the map to guide me to when I'm paged, for example. And so what this map is highlighting, let's say, 4 services in red, they breaching their service level objectives. And besides that, every component also shows its like a health circle that shows a breakdown between server faults, user errors, and successful requests. And you can kind of gauge from that where the problems are. First of all, what's highlighted in red. Second, if let's say you didn't set up any service level objectives, you can just gauge from that circle. The more red means more problems, essentially. And you can instantly go and inspect each component and get this operational audit And for example, in this case, I get a whole bunch of, these audit cards that tell me, we have this problematic dependency, and it said like some, unhandled edge case, etc. And this one is interesting. One of the auditors will try to find an outlier. And by outlier, I mean some of the resources, like a pod or a node or EC2 instance, that contributing the most to errors or to high latencies in your application. So this audit card is finding exactly this scenario, suggesting that you would want to recycle this resource, right? But it's all good and great knowing what's happening on the server side. But sometimes we don't have full visibility into what's happening with what the client experience is. Because the server-side instrumentation gives us so much, right? And for that, there are two techniques that CloudWatch suggests you could use. One is synthetic canaries. So this is an example of a whole bunch of different synthetic canaries that continuously running, executing APIs and validating that the responses actually match the expected results. And you can see they're actually not always succeeding. There's only 96% success rate. But there is also, they called synthetics for a reason. So they not fully represent the actual customer experience. And to measure that, CloudWatch has real user monitoring. So real user monitoring is essentially a set of APIs, including the client-side SDKs that you can use to instrument a website. So like this example is the app monitor that it's just essentially a bunch of JavaScripts that included with a website that continuously measuring and reporting back home about how these pages are loading, how fast, are there any JavaScript errors, etc. And what we just recently launched is a similar client-side instrumentation for Android applications and for iOS applications. So that way, when you look at this application map, you're not only seeing how your services are performing, but you're also seeing what your customers are experiencing. And so from this picture, I could say that, like again, this health status circle, it tells me that, well, the Android customers are really having a bad day. I have too many crashes, like also server faults. And these graphs, they kind of support that. They're just saying how historically those issues have been happening. So at this point, I would like to troubleshoot more and get to the real user monitoring part of the AWS console. So in here, real user monitors in Application Signals, they connected with the service that this client applications are hitting first. Like in this case, it's a pet clinic front end. And I have 3 different real user monitors for this microservice. So this one is for website, this one is for, this one for iOS, this one is for website, and this one is for Android. And I could tell from here, from details, which pages or screens actually having issues in an Android application. And so like this is a number of crashes. And so the owner details activity is the one that has the most problems. To troubleshoot even further, like first of all, I can go and use Android Studio so I have it preloaded, to validate, like, is this actually happening? So I can go check on list of all the owners. So I'm running a simulation of this mobile app. And when I click a individual owner, it essentially resets. So I do see that this application is crashing on that particular screen. So to root cause it even further, I can click on any data point on the crashes graph, and we'll get like essentially a list of sessions that resulted in application crashes. So this data is transferred from the mobile app to RUM service. And at this point, I can just spot check. For example, I pick a session, and I get transferred to RUM console. And then here, I can look at the exception. So this is the stack trace for this exception. I can just go and transfer it back to the Android Studio, analyze this stack trace, and essentially go to the line that causing the issue. Just help me to understand where I need to implement a fix. So enabling RUM for mobile, and I'm going to show for Android, very straightforward. So there is one dependency you need to include in your build file, which is Hotel SDK, but it's packaged by Amazon. We just picked all the pieces needed from Hotel to support that functionality. And you also need to create app monitor and specify it in the configuration file that this application will be recorded through this RUM monitor, and just specify the region where the telemetry will flow. And that's how to set it up. And if I go back, just one thing I wanted to summarize is that application map is acting essentially as a guiding tool. You can think of it as a dashboard, but interactive dashboard. From this dashboard, you're not only looking just at metrics and graphs. You're looking at your life system, how it performs at the moment, or historically. You can go and check different time. Let's say if you're investigating an event that happened last night or 2 weeks ago, you can change the time frame and go back to that time and see. It will historically show how your system behaved at that time. And you're not only seeing how your service is performing or how your resources responding to requests, but now you also, with mobile RUM, you can also see end user experience, and essentially that way oversee all your distributed system from start to end. So application signals, what it does, it after you instrument it, it actually connects metrics, logs, and traces together. So, for example, in Lambda, it's pretty straightforward. There's Lambda logs and traces and metrics. For, let's say, EKS, it's a little bit more involving, but it's still, relatively straightforward. So, in fact, traces in CloudWatch, they do report, they connect which log group to go for corresponding logs. And so, I can show one of the examples. So when I'm troubleshooting this service, let's say this is a microservice, could be EKS and I have this bunch of operations, and this operation is obviously failing. And at this point, this is where the sidebar connects all all this other telemetry. So on the left, you see the metrics. Here you see correspondent spans to the metric. But this is the link to application log. And the similar would happen for, let's say, EKS application log. And you can, let's say, application signals could not connect the dots. You could customize your trace attributes and add which logs to look for when that trace is emitted.
And also, we have maybe you want to show the transaction search feature. So what we do is we take your transactions in terms of traces and then convert and then store as logs. So that way, you can go ahead and then just search for it, anything. So an ideal use case could be if you are maybe a support person and then you are getting a call and then the customer is saying hey, my order is not going through. All you need to ask them is hey, what is your order number? Just go to the transaction search page, click that order.id is 123, something like that, right? And then the moment you click enter, it is going to take all the traces or all the transactions that has happened in the last 3 hours, for example, and then it will show you all the transactions in that one, wherever we are using this order ID is 123. So this is finding a needle in the haystack kind of a situation. And with this transaction search feature, because we are taking your traces and then storing as logs, you can do all kind of operations, typically however you're doing it with your logs, right? So maybe, so this is what the transaction search feature is. So Alex can guide you on that.
Yeah, the transaction search already also getting benefit of discovered services. It will help you, it will suggest, okay, you can search through this microservice, through this API, and it will also help you with which fields you can specify in here. And maybe some of the fields will be, this is my request ID, I know the request, or this is my order ID. And you can that way nail down. But I think the point what Shiva was making is that traces in application signals, they store that as logs. And that way you can use log analytics essentially to better reason about your application behavior.
If I've already instrumented for X-ray, will I need to instrument again for open telemetry?
No.
Okay.
There is one, caveat. So when X-ray originally launched, it has its own SDK, which is we announced as on deprecation path quite a while back. And I don't know, some people still use that, right? That X-ray SDK. But I guess starting a few years back, we announced that moving forward, OTel SDK is the one that X-ray will support in the future. And we call it Amazon distribution of OTel, ADOT. And the reason for that, actually all of that, you can assemble it yourself as well. It's all in public repo. We just pre-build it so it's easier to make sure all the necessary pieces are in one place.
So this particular QR code has a bunch of links. So if you want to see that, so whatever Alex has talked about, all these things are available in that one observability workshop. So we have application signals demo also. So all these things are interactively available so that you don't have to create any accounts and then try out those features. So, and also we have a YouTube show called Cloud Operation Show. So that runs every 2 weeks, Thursdays. So that recorded videos are also available there. And we do have a separate observability best practices guide. So we have been talking to hundreds of customers and we identify the patterns and then we document all that information. So that information is also available. Please take a look into it. And then if you have any interest, any follow-up or anything, please reach out to us. So this is our LinkedIn handles. Please feel free.
Thanks, everyone.
Thank you, everybody.
Thank you.